Hi students, as you know about me, I am TB Marigodar, HOD of Mathematics, Nehru Arts Science and Commerce Degree College, Hubli. So it is the continuation of the Laplace transformation of BSc 5th semester Mathematics. In the previous classes, we did the derivation of convolution theorem and one variety of the example in the convolution theorem. In this class, to go for the another variety of the examples in the convolution theorem. Before that, recall what is convolution theorem. As convolution theorem state that L of f of t star g of t is equal to L of f of t into L of g of t. We did the examples also on this one. In terms of inverse, we can write this convolution theorem as just transfer this L towards the right side, that is f of t star g of t is equal to f of t star g of t is equal to L inverse of L of f of t into L of f of g of t, or in other words, L of f of t star g of t may written as L inverse of f of t star g of t is equal to L inverse of f of t into L inverse of g of t also. Now to take over the second variety of the examples in the convolution theorem, finding the inverse using convolution theorem. The example, find L inverse of 1 divided by s plus 1 into bracket s plus 3 using convolution theorem. Take the solution of the type. How to find out the L inverse of inverse Laplace transform using convolution theorem. Especially there is L inverse of product of the two function is given. In the denominator there is the multiplication of s plus 1 and s plus 3. So you may write this as L inverse of separately 1 divided by s plus 1 into 1 divided by s plus 3, because as the multiplication you may split the expression directly. Now here it is f of t is 1 divided by s plus 1, g of t is 1 divided by s plus 3. So you can split by means of convolution. L inverse of 1 divided by s plus 1 star L inverse of 1 divided by s plus 3. Now we know that what is L inverse of 1 by s plus 1? It is the exponential answer e raised to minus t star, it is e raised to minus 3t. Now these two are the convolution of two functions f of t star g of t. Just recall convolution, f of t star g of t is equal to integration from 0 to t f of u into g of t minus u du. F of u into g of t minus u du. So we can write integration from 0 to t. What do you mean by f of u? E raised to minus t is in terms of u e raised to minus u. So the first function f of u means e raised to minus u into e raised to minus 3t treated as a g of t as g of t minus u. It is e raised to minus 3 into bracket t minus u with respect to u as du. So we have integration from 0 to t. Keep the e raised to minus t as it is and multiple this 3 to the bracket. It is e raised to minus 3t into e raised to plus 3u, because minus of minus into du. So It is with respect to u, therefore e raised to minus 3t is a constant. To put e raised to minus 3t outside the integral sign, remaining sign, integration from 0 to t, the e raised to minus u and e raised to 3u is simplified as a e raised to 2u du. Now it is the e raised to 2u integration, e raised to 2u by 2 with limits 0 and t. Now to substitute the upper and lower limit, once at u equal to t and another time it is u equal to 0. So it is, there is outside the bracket already e raised to minus t is there, e raised to minus 3t is there. So we have e raised to minus 3t into bracket upper limit minus lower limit, u is replaced as t, e raised to 2t divided by 2 minus u as 0 means e raised to 0 divided by 2 as a 1 by 2 because e raised to 0 is 1. Now multiply this e raised to minus 3t, simplify, we get the answer e raised to minus t minus e raised to minus 3t divided by 2. Therefore L inverse of 1 divided by s plus 1 into s plus 3 is the e raised to minus t minus e raised to minus 3t divided by 2. So this is the required answer, and this is the method that finding the inverse with the help of a convolution theorem. We can go for the another example of the same variety. Find L inverse of 1 divided by, I will go for s into bracket s square plus 1. In the denominator product s into bracket s square plus 1. Go for the solution, usual method. L inverse of 1 divided by s into s square plus 1. As the product, you may split directly L inverse of 1 by s into 1 by s square plus 1. You can write this as a L inverse of 1 by s star L inverse of 1 by s square plus 1. So as you know that what is L inverse of 1 by s, that is a 1. Because L of 1 is 1 by s, immediately L inverse of 1 by s is 1. Between that star, L inverse of 1 by s square plus 1 is direct result as a sin t. Because sin t equal to L inverse of 1 by s square plus 1, hence L inverse of 1 by s square plus 1 is sin t. Now here it is f of t is 1, g of t is sin t. These two are convolutions. It is integration from 0 to t. I will write f of t as a f of t minus u. F of t is 1. Immediately f of t minus u is also keeping as 1 because constant. Second function g of t is written as g of u, that is sin t is written as sin u du. That is by convolution f of t star g of t equal to integration from 0 to t f of t minus u into g of u du. So we have integration from 0 to t, only the sin u integration is minus cos u with limits 0 and t. So put u equal to t minus u equal to 0, upper limit minus lower limit, outside that minus of cos t minus cos 0, minus of cos t minus cos 0 is a 1, multiple minus to the bracket, we get a 1 minus cos t. Therefore L inverse of 1 divided by s into s square plus 1 is equal to 1 minus cos t. So this is the answer. So this is the method of finding the L inverse of product of the two functions has been given using convolution theorem. Next, to go for the One more third variety of solving the convolution theorem examples. The first two varieties are very important for the examination, no doubt. The third variety, it has been, why not it is asked in the examination. We are observed the so many question paper, but not asked till. But do not neglect such examples, because the application of convolution theorem will be appear in this example also. Solve the integral equation f of t is equal to a into t at plus integration from 0 to t f of u into sine of t minus u du. So this equation is called the integral equation because this expression containing the certain term as a integration. The second term, integration from 0 to t, f of u into sine of t minus u du. Often it is the convolution definition of f of t star sine t, okay. But to try to avoid this integral part, using convolution and simplify and find out the solution for the expression. So we have f of t is given. My idea is to apply Laplace transform towards the left and right side. Apply L on both the sides. That L is nothing but the Laplace transform. Apply Laplace transform on both the sides. L of f of t is equal to L of whatever it is given, the RHS part, at plus integration from 0 to t f of u into sine of t minus u du. Keep the left side L of f of t as it is. Now apply L to the both the bracket terms by linear property, L of a into t plus L of the second part is nothing but the convolution function f of t star g of t, where f of t is a f of u, g of t minus u is a sine of t minus u. F of t star g of t becomes f of t star sine t. Just recall the convolution, we get the clarification. This one, integration from 0 to t f of u into sine of t minus u. I written f of t star sine t. Now keep L of f of t on the left side as it is. So L of a into t, t is the variable, a is constant, therefore we can write a into L of t plus L of f of t star sin t is split by means of convolution, L of f of t into L of sin t. The right side expression remains same. A into L of t, L of t is, we know that 1 by s square. Direct answer, L of t by convolution. By direct Laplace answer, L of t raised to n result. That one, L of t is a 1 by s square. Keep L of f of t as it is. What is L of sin t? 1 by s square plus 1. Look at both the LHS and RHS. L of f of t is in right side and L of f of t is in left side. It is 1 into L of f of t in the left side and L of f of t divided by s square plus 1 in the right side. Taking that into the left side, L of f of t is already minus this one, L of f of t divided by s square plus 1. The remaining is a divided by s square. Taken L of f of t common in the first two terms of left side. What you left in the bracket? 1 minus 1 by s square plus 1. No changes in the right side. A divided by s square, keep as it is. L of f of t, and simplification by means of LCM in the bracket. LCM s square plus 1 multiple s square plus 1 minus 1 divided by s square plus 1. Cancel the plus 1 and minus 1 is equal to a by s square. Keep L of f of t is only left side. Remaining term can be taken into the right side. That s square into s square becomes s raised to 4. And this s square plus 1 goes to the numerator. So s square plus 1 by s raised to 4. Only f of t is L inverse of the bracket s square plus 1 by s raised to 4. Split that one, s raised to 4. So we have L of f of t equal to L inverse of 1 by s square plus L inverse of 1 by s raised to 4. A is there, I am not written, you to be right, A into bracket, the remaining thing. RHS I am not written A, you to be right, A into bracket, L inverse of 1 by S square is a T, and L inverse of 1 by S raised to 4 is a T cube by 3 factorial. Therefore, the answer is f of t equal to A into bracket. Once again, I am telling A into bracket. T plus T cube by 3 factorial is a 6. T cube by 6. So, this is the required solution of the expression f of t equal to At plus integration from 0 to t f of u into sine of t minus u. I said that A was I was not written A in that step. So this is the f of t is A into bracket t plus t cube by 6, which is the required solution. So students, we did the 3 varieties of examples on the convolution theorem. Convolution theorem is the most important part in the Laplace transform. In the examination, there should be theorem always, where state and prove convolution theorem, and example should be. So now to take some examples as worked examples as exercise. Find L inverse using convolution theorem. So I will write the question using convolution theorem. Find L inverse of 1 by S square plus A square whole square. The second one, same question. Find L inverse of using convolution theorem. Find L inverse of 1 divided by S minus 2 into S minus S plus 4. Okay. That's the third variety. Solve the integral equation. Solve the integral equation. F of t equal to cos t minus 2 into integration from 0 to t f of u into sine of t minus u du. So students, to solve these 3 examples using the worked examples. In the next class, I will send the hard copy of these notes and continue the Laplace transform in the next